Hi everyone, thank you so much for tuning into AWS reInvent today. This is session game 301, How Zynga Modernized Mobile Analytics with Amazon Redshift RA3. In this session, you'll learn about how Zynga migrated data generated by tens of millions of players from their existing infrastructure to Amazon Redshift. My name is Gina Gizzi. I'm the AWS host for today's session, and my role is as a solutions architect for AWS Game Tech, where I help games customers like Zynga, for example, leverage AWS services and technologies to make great games. I'm super excited to be here today with Bharath, who's a data architect at Zynga, who will walk us through Zynga's data migration. But before that, I do just want to do a quick introduction to AWS Game Tech and analytics on AWS. So what is AWS Game Tech? Well, whether you're a team of 1 or a team of 1,000, the most important thing to you is creating a game that players want to play, right? And how you get there is the real question. And that's where AWS Game Tech can help. Game Tech provides robust and scalable solutions for every stage of your game's lifecycle, whether it comes to the AWS services that we offer, our Twitch integrations, or even our managed game services like Amazon GameLift, for example. Here at AWS, we also have a pretty big analytics ecosystem where we have a lot of services and features within those services that can help at every stage of building out a data analytics pipeline, whether that's from data movement and ingestion or a data lake infrastructure and management, analytics and ETL, extract, transform, and load, data visualization, or even things like machine learning and live ops. As you'll see in this session today, Zynga is using our AWS analytics services for their very own data analytics pipeline. And for example, just to name one, of course, they're using Amazon Redshift as their data warehouse, which is the main focus of this session here today. And with that, I'll pass it off to Bharath to tell us a little bit about how Zynga modernized their analytics with Amazon Redshift.
Thanks, Gina. Hello and welcome to the talk. I'm Bharath, architect on the data engineering team here at Zynga. Before we jump into the actual content, here's a little bit about who we are. Zynga is a leading developer of the most popular social games that millions of people around the world play each day. Social gaming commonly refers to playing games as a way of social interaction, as opposed to playing games in solitude. Our mission is to connect the world through games. As some of you might already know, we have a wide variety of titles including Farmville, Zynga Poker, Words with Friends, CSR2, Game of Thrones slots, etc. Now here's a trailer for one of our most recently launched games.
Embark on a most magical matching adventure, celebrating the world of Harry Potter. Use fantastical abilities and solve rewarding puzzles. Level up your skills by unlocking and upgrading spells. Collect charming and mischievous creatures who will aid you in overcoming curious challenges. Play with friends and share the adventure as you swish and flick through boards inspired by your favorite characters and iconic moments from Harry Potter. Become a master of puzzles and caster of spells on a captivating journey. Celebrate the magic of Harry Potter. Puzzles and spells. Download today.
So hope you all download the game and give us feedback about the game as well. In today's agenda, we'll talk a little bit about the importance of analytics at Zynga. We'll then discuss what prompted us to migrate to something that's more scalable. We'll touch a little bit about some of the data warehouse solutions in the market and why we picked Redshift. We'll also share a database scorecard to help plan future migrations. We'll then dive a little bit into the migration process and some of our learnings. Now we talk a little bit about why analytics is important, and especially at Zynga, since we have such a huge data-driven culture for product design and optimization. Put simply, analytics in gaming boils down to using data to drive decisions about what to change or add to our games. This is broken down into 3 high-level steps. Having the data we need to make those decisions and making that data more accessible. Then analyzing that data to understand what our players like or don't like about our games. For example, how our players can be segmented and what new features our players might have an appetite for. And making changes in our games to personalize and make player experiences more delightful. Analytics is a critical component of Zynga's culture of being objective and data-driven wherever possible. This holds true for launching new games or for growing existing games. While we have people who can make great decisions when the data is available, but without a robust analytics infrastructure, we can't help them inform those decisions. While there is a diverse set of tools and products out there for data infrastructure, the space is constantly evolving. Choosing the right set of tools for your data infrastructure solves half your problem. Now, at a high level, here are some of our metrics in terms of orders of magnitude. We have tens of million mobile monthly active players across all of our games. The game actions from these players generate about few terabytes of uncompressed data per day. And this amounts to around tens of billions of records in total per day. And on the compute side, we run a few million queries per day. This is a mixture of our queries from our data ingestion pipeline, reporting queries, ETL queries, monitoring, data science, and other queries. Our data needs and use cases have grown dramatically over the last 2 years. While our data warehouse worked great for us, it's no longer able to keep up with the growth we've seen in data and query volume. Our needs as far as storage and compute go have grown significantly. However, our data warehouse can scale to meet our demand in a completely automated fashion without a large amount of manual work. I'd like to first talk a little bit about why we wanted to migrate away from our old data warehouse and why Redshift was the best choice for us. Okay, so now we can answer the question, what do these stats mean as far as tangible impacts on how Zynga uses its data? Let's walk through a common example of the pain points we experience with our old warehouse. This isn't every day, but it most definitely isn't considered rare. It's a typical Monday morning, and our central ETL, which kicks off usually around 15 minutes past midnight, has just completed. This is the industry standard overnight ETL that computes game and player level metrics to power some of the standard KPIs. The dependencies are now met to trigger several downstream game and partner teams' ETLs. Right around 9 a.m., query queue has jumped from 15 to around 100. Why is this happening? Because resources are all tied up running other ETLs, and we have hit the limit on our compute resources. Ingestion lag has jumped from 10 minutes to over 100 minutes. Product managers have gotten to a point where they run a query, then go grab a coffee and a muffin and hope the query has completed by the time they're back. But it probably hasn't. The data engineering team is all hands on deck, weeding out long-running queries that are causing a bottleneck and are actively load balancing between the 2 production clusters. And this is just the morning. Let's look into why that's the case. I want to highlight some shortcomings of our current warehouse. Let's talk a little bit about inability to scale storage. We only have the capacity to store approximately 8 weeks worth of data for most of our queried categories. This prevents us from doing long-term experiments and limits our ability to train predictive models. The warehouse is inelastic. We leave the cluster in an over-provisioned state since we can't scale up and down resources according to our needs. This wastes resources and causes us to spend more than we need to in order to run our day-to-day operations. There's also high maintenance costs. The team spends about 45 full engineering days per week on ops support work. Due to the unreliability of our systems, we need to keep a secondary cluster running with duplicate data, which in itself creates a lot of maintenance work. And lastly, we're currently spending as much or more than the cost of leading market solutions for a much lower value. So now let's talk about why Amazon Redshift. The table below lists the criteria that we use to evaluate market solutions. The criteria are listed in top to bottom order in terms of priority. Note that this evaluation criteria is for Zynga, and criteria across different companies might differ. I want to caveat this by saying that the evaluation was done around March and April of this year, so some of the product offerings might have changed from then until now. The main thing we wanted to get out of the new solution was the service for it to be a managed service that doesn't require a lot of maintenance from our end, and a system that can scale with our business needs, both in terms of storage and compute. Beyond that, table stakes metrics like cost and performance come into consideration. Finally, towards the bottom, you can see that we wanted to consider what this solution might look like for us in the immediate and in the long-term future. Here's where our old data warehouse stacked up against the criteria. As you can see, it scored very poorly in terms of maintenance, scalability, and storage. Performance was adequate when the system was healthy, but that state was far from the common case. The values here are on a scale between A+ and D-. The two solutions we ran an in-depth proof of concept were Solution B and Redshift using the new RA3 instances. Both proof of concept took several months. The POC involved us setting up a cluster and running an entire suite of tests to understand how the product performed within the context of Zynga's use cases. Market Solution B was an excellent solution as far as maintenance overhead goes, and it's an entirely managed system that's presented as a service. All the maintenance details are abstracted away, and you can just trust that things will work without having to touch anything under the hood. It also was very strong when it came to scalability and storage. The areas where we felt it didn't really meet the bar was the cost, given the lack of controls on the scaling of resources. Given Zynga's history of constantly growing data needs and having a keen focus on data-driven decision making, especially in machine learning workloads, this cost was not desirable. Additionally, given the differences between our legacy system and Solution B's query language, we estimated a massive migration cost for all the rewrites that we would have to do. From our perspective, Redshift performed comparably to our legacy warehouse in terms of maintenance, overhead, and scalability at a much lower cost. This includes base costs as well as anticipated scaling costs. We were also impressed by Redshift's performance on our heavy-duty workloads. It was able to cut down the runtime of our main ETL by more than 30% without any additional scaling. Finally, towards the bottom of the criteria, you can see that coming from Zynga's current AWS infrastructure, Redshift was highly compatible with our current technologies. Since Redshift is based on Postgres, it made the migration a much more digestible task. We're only about 4 months into our migration, and we're already more than a third of the way through the entire migration process. We're also very excited to see what new releases Redshift comes out with in the next few years. The improvements on the roadmap look very promising. Now let's talk a little bit about the migration itself. At a high level, this is what our current infrastructure looks like today. The client hits one of our services. After navigating through a few of our other services, the data finally lands in Kinesis. Once the data is in Kinesis, we're able to add any number of consumers for different use cases. I've highlighted only a few here, but to the right, you'll see we have a Kinesis S3 consumer, which reads the data from Kinesis records, batches it up into a file, and dumps it into S3. Then we have consumers, what we call loaders, that load the data from S3 into our warehouse. Because we currently don't have the ability to store more than 8 weeks of game events, we have an archiver job that pushes older data in an open format into our data lake S3 bucket. For the purposes of this talk, we will just be focusing on the highlighted section in the top of mostly our migration specifically. The first phase of migration is the actual deployment of our Redshift cluster itself. For those of you that don't know what Terraform is, it is one of those infrastructure as code tools. It's great for building, changing, and versioning your infrastructure, and in this case, we use it for modeling our Redshift infrastructure through code. We wanted every change to be documented and reviewed, and didn't want engineers to make changes on the console. In Zynga, we have always had many different warehouse clusters. These clusters could be of different sizes that serve different purposes. For example, our dev cluster has data for games that are either in development or that are in company playtest. We then use Jenkins to automate all of this. This is quite useful since the console log contains the Terraform plan, which shows what infrastructure was modified during the run before it can be applied. So what did we achieve? With a single click of a button, we're able to spin up multiple Redshift clusters or make changes to the Redshift resources, such as an IAM policy or an access to an S3 bucket, or changes to WLM to control queues and resources. Now let's talk a little bit about the data migration. This step of data migration includes setting up new consumers for data ingestion into the Redshift cluster. The parallel ingestion helped us iron out all the details with ingestion table design, where we had to get a perfect balance between compression and performance. We were also able to fine-tune our thresholds for ingestion by having a minimal impact on our SLAs. The staging files on our S3 buckets are compressed. Loading compressed files not only provided a performance boost, but also saved money on our S3 bill. We changed the way we load data into Redshift and took advantage of a manifest to specify how many files should be loaded at what intervals. In our case, the manifest file gets generated every time a certain threshold is reached. For certain categories, the manifest contains several files, and we were able to take advantage of Redshift's slice-based parallel processing. For performance, we just used the standard number of megabytes loaded per second, and to our surprise, we saw a huge improvement in copy performance. Every stat or data point that we collect has a server timestamp attached to it. This helped us establish a high water mark for the data to be migrated from our legacy databases. So we set up views that acted as an abstraction layer to expose the queryable data. The green area here indicates the queryable data through a view. To make sure that the ingestion performance wasn't degraded, we decided to push our historical data from a legacy database into a new table. We set up tools to export data from our legacy warehouse into S3 and then ingest them back into Redshift using copy. This also made sure that the data in the ingestion and the historical tables were ingested in the order of sort key to avoid needing vacuum. This wasn't always the case, but we made sure that the impact was minimum. At the same time, we altered the view to expose the newly exported data as well. As an added feature, we were able to use Redshift Spectrum for our older archive data as well. For those that aren't aware what Spectrum is, it's a feature within Redshift Warehouse service that enables data exploration on objects stored on S3. The late binding views in this case was a union of a Spectrum table and two Redshift tables, each exposing data for a specific date range. Now the ETL migration. We use Airflow for a majority of our ETLs. Airflow is an open source workflow management system that allows us to programmatically author, schedule, and monitor workflows. As a first step, we developed reusable Redshift components for Airflow that included certain operators and hooks. For ETL migration, we followed best practices that was iterative in nature, starting with the source of lineage. And as and when a certain SQL function wasn't available in Redshift, we were able to quickly build Redshift UDF to fill the gaps. Successful migrations include data profiling and data quality. We developed a simple parameterizable notebook that took inputs and compared data quality for ETL outputs between our legacy system and Redshift. We moved the historical data to Redshift once the data was validated. We built certain tools and Airflow workflows to achieve this. The simplest approach was to push the data out of our legacy warehouse as Parquet into S3 and then copy it back into Redshift. Since we saw a huge improvement with Spectrum tables, we were also able to leave some of the older historical data in our data lake S3 bucket and exposing them in a Spectrum table without ingesting it into Redshift. When the ETL was marked as production in Redshift, we stopped our ETL on legacy warehouse and instead pushed the ETL output from Redshift into our legacy warehouse so the end users could still query the latest data on our legacy warehouse. This approach also made sure that we didn't have two code bases for too long. Here you'll see that we're repeating the process, deprecating old workflows on legacy system and picking up new ETLs on Redshift. Overall, we're seeing a huge improvements to almost all of our ETLs. Here are some of the key takeaways. We saw benefits in performance when multiple statements ran within a transaction. Definitely use this when you have a paradigm of multiple drop, create, insert statements within an ETL. Also, there's no need to constantly run vacuum, but find a cadence to run vacuum that gives you the best improvement on all your ETLs. In our case, we're currently running vacuum on a select few tables every few days. Load your temporary tables in sort key and distribution key orders so that it benefits most of your downstream joins. Certain ETLs use a select within an unload as a performance optimization. We can then use copy to move the data back into Redshift or expose it in an external table. Now moving to the next phase of migration, which is consumer migration itself. With data democratization, most people at Zynga have access to some level of data, and we've seen a wide range of clients that connect to our warehouse for different needs. The migration helped inspect query usage across different clients and standardize them. Most of this work is still in flight, and we're still investigating queue processing behaviors and working on creating query routing rules to adjust our WLM. And here you see that different users or service groups within Zynga can use any of these clients. For example, data scientists can use the Tableau, Airflow, Databricks, dbeaver, etc. As we hunted down, we found connections to our current warehouse from various different clients using different libraries. To get everyone to configure drivers and manage connections was quite a painful task to manage. To solve the issue, we're currently exploring the option of using Amazon's Redshift Data API. This feature was recently released. The Data API simplifies data access from different programming languages and platforms, thereby improving developer experience. It also eliminates the need for configuring drivers and managing database connections. The Data API is asynchronous, so you can query your results later. The query results are stored for up to 24 hours, so we can retrieve the same result using the get statement result along with the query ID. It can be used by any programming languages supported by the AWS SDK. It also federates IAM, so we can rely on identity providers and not pass credentials for the API calls. And now, although we haven't finally reached the stage of the migration yet, this is how we plan to end of life our legacy warehouse. Mostly to over-communicate the timelines, stop upstream services and lock user accounts, and then monitor for any activity, and finally take a backup and shut down the system. So here are some wins post-migration. So we're seeing a consistent ingestion lag with migration. So we're able to reduce the ingestion SLA by 30%. The copy performance has increased massively through our data ingestion pipeline. The ETL performance also saw a huge benefit when we migrated some of our ETLs to Redshift. We can now scale as needed without having to over-provision our clusters and leave it like that all the time. We're now also able to do long-term analysis since we can store more than 8 weeks of data on Redshift. By doing all this, we are also able to reduce our analytics-related AWS hosting costs. Now, apart from meeting all of our evaluation criteria, Redshift's product roadmap and their future product offerings closely align with our data infrastructure needs, and we are excited to take the platform to the next level. One such example is the adoption of Redshift Data API. And finally, there has been great collaboration between our team and the AWS team. Huge thanks to the solutions architects, account managers, and enterprise support team members to keep the migration moving forward when things were looking bleak. So what's next? Spectrum, Athena, Glue unlocks building blocks for Data Lake. So we want to build a robust, queryable data lake next year using some of these features. Like you saw, we've improved the data ingestion process and are able to ingest data at a much faster rate. So the current ingestion opens up more opportunity for near real-time analysis. Finally, we want to use the Amazon's Redshift federated query feature to query and analyze data across other operational databases or data warehouses and data lakes at Zynga. Thank you for watching our session today. Let us know your thoughts by answering the survey below.